Hello and good evening, everyone. Welcome, Phil. Phil, we've been collaborating already for a number of years already, since 2017, almost 6 years.
Yes.
You've taken some key roles at some of our customers like Proximus and BNP Paribas Fortis now. And it's been a while you're actually evangelizing about DDD.
Yes.
It's been a while you're telling us about domain-driven design, and we thought today is maybe the opportunity for you to share your thoughts. You've trained yourself a lot on the matter, and today you accepted to share your knowledge with us. So thank you in advance, and I leave the floor to you. We listen to you.
Thank you, Louis.
Welcome.
Good afternoon, everyone. Today, I would like to speak to you about a powerful approach to software system development. In the world of software development, building complex systems that reflect real-world domains can be a challenging task. And that's where DDD comes in. Provide us with a set of principles and practices to develop software that align closely with the problem domain we are given and trying to solve, of course. Okay, this is a terrible slide. Don't look at it. So DDD is not just another buzzword or passing trend. It has gained significant recognition and adoption in the software development community over the years. It has proven to be effective in developing robust, maintainable, and scalable software systems. Before we dive deeper in DDD, let's maybe take a step back and consider the traditional approach of software development. In many cases, the focus is on the technical aspect of the software, like framework, libraries, or database. And while these are important and necessary, they often take the spotlight away from the very core of our software, which is the domain. So domain-driven flips this approach on its head. And instead of starting with the technical details, DDD places the domain at the heart of the software design process. By understanding the intricacies of the domain and aligning our software with it, we can build systems that are more expressive, easier to maintain, and ultimately more successful in meeting our customer needs. How well one can solve a problem is determined by how he understands the domain. Developers are smart people, but they can't be specialists in all fields. They need to collaborate with domain experts to guarantee that the code is aligned with the domain it's trying to represent. The problems. Yeah. Since DDD is changing the way we are working, it's interesting to first see what are the problems. Often there is a communication gap and understanding between the domain expert and the software developer. And DDD encourage the collaboration and the development of shared ubiquitous language, bridging this gap and ensuring that the software accurately reflects the domain. There is, of course, the complexity. So yes, developing a software system that reflects real-world domain is challenging. And DDD provides techniques to break down complex domain into manageable components, such as bounded context, aggregates, entities. This helps in reducing the complexity. There is also, like I said, the technical focus development. Traditional software development approach often prioritizes the technical details over the understanding of the domain. DDD promotes focusing on the core domain and aligning the software design with the business requirement, ensuring that technical decisions are driven by the needs of the domain. By addressing this problem, DDD aims to improve the collaboration between domain experts and developers, increase the maintainability of software systems, and enhance code quality. Yes, what is a model? Since DDD is mostly about modeling, let's have a quick description of what developers mean by a model. In its essence, a model is an abstraction which allows us to handle the complexity by omitting unnecessary details. The purpose of this abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. A useful model is not a copy of the real world. Instead, a model is intended to solve a problem, and it provides just enough information for that purpose. As a real-world usage of model, we have maps. We have different projections, which are different models, and all of them are there for different purpose. For example, the Mercator is good to know when you want to navigate, which direction you need to take, but it completely distorts the landscape. So you cannot use it to compare the size. If you look at Mercator projection, for example, the Arctic here is as big as the South America, but it's clearly not the case. There are other projections that clearly show that. So different model for different purpose. Domain modeling. Domain modeling in DDD enables the creation of a conceptual model that accurately reflects the problem, align with the Ubiquitous language, and provide a solid foundation for designing and implementing the software system. It helps in understanding and managing the complexity, improving communication, and ensuring that the software system is closely aligned with the business needs. Understanding and capturing the core concept, rule, behavior, and relationship of the problem domain is needed to gain deep knowledge of the domain from domain expert and translating that understanding into a conceptual model. The Ubiquitous language domain modeling is closely tied to the Ubiquitous language. It ensures that the language used in the domain model aligns with the language used by domain expert, making the model more expressive, easier to understand, and closer to the domain reality. And then there are bounded contexts. Bounded contexts define specific boundary within which the domain model is valid and coherent. They represent areas of the problem domain with a clear focus on separate contexts where different models, terminology, and rules may apply. Bounded contexts help manage the complexity of large domains and facilitate the scalability and maintainability of the software system. The Ubiquitous language. It is a common language used between domain expert and software developer, and it is there to bridge the communication gap. It has a domain expert's perspective because we want to use the same language in the software, in the model that the domain expert. So it alleviates all misunderstanding when communicating with the domain expert. It promotes the consistent use of that language in all the process of the software development, so that everyone is know what we are talking about. What is the all the term and terminology should be clearly defined in the Ubiquitous language, and of course this language should reflect in the code, in the class, in the method, in the variable, for readability and maintainability of the code. By embracing and consistently applying a ubiquitous language, DDD ensures that software development teams develop a shared understanding of the problem domain. This understanding is crucial in accurately modeling the domain, capturing the business needs, and delivering software system that effectively meets the needs of the stakeholder. The bounded context. Bounded context is a central concept in DDD that defines a specific boundary or context within a software system where a certain set of model, rules, and language apply. It represents a cohesive area of the problem domain and provides a clear context for understanding and developing a particular part of the system. A bounded context helps manage the complexity of large and intricate domains by breaking them down into smaller, more manageable parts. It's important to note that bounded contexts are not strictly technical boundary, but should be based on the problem domain itself. They are defined based on the different concept, rule, and language used in the specific area of the domain being modeled. Yes, the difficulties encountered are multiple. There is a steep learning curve because there are new concepts, new terminology, like the ubiquitous language. I'm not even sure I can pronounce it correctly. This understanding effectively may require investment of time and effort of the whole team that will be involved, software developer and domain expert as well. The communication and collaboration can also be an issue because it's not always easy to have the domain expert available to gain that the understanding of the domain. They may also have organizational resistance, for example, from the stakeholder who are not familiar with or skeptical about the benefit DDD offers. And overcoming this resistance may require education, advocacy, and showcasing successful case studies. And of course, there is the trap of over-engineering. And the team need to strike a balance between keeping the solution simple and using and applying DDD where it needs really. So despite these difficulties, the benefits of DDD, such as improved collaboration, maintainability, and domain alignment, often outweigh the challenge. By investing and learning effective communication and iterative improvement, organizations can overcome these difficulties and successfully implement DDD to create high-quality software system. So that already concludes my introduction on DDD. If you want to dig more dig more on the topic, I can recommend these two books. So there is the Blue Book from Eric Evans, which is kind of a reference in the topic on the topic, and then there is this one from Vlad Konovov, which is more practical with more samples. I really liked the book from Vlad, and that's all. Thank you all for your attention. If you have questions now, please. Anyone?
I'll start with one question. Thanks a lot, Phil, for sharing your insights. Do you know some concrete examples in Belgium, some concrete implementations around us that are using DDD?
DDD was introduced to me by the architect at Proximus on the Pix application. And so far it's the only one where it was properly, well, truthfully applied through the development process of the software. Yep. It sometimes amazes me because it's not a new concept. It's already been there for about 20 years. It wasn't part of those domain concept and wasn't part of my courses, but I think it should really be, because in the end, especially now with like now we are talking about the AI that one day can replace developers. Well, it's impossible to tell how it's going to be in 10 years, but the domain will always be something where the AI will struggle to learn and solve the solution. They can solve issues like calling a web service, displaying something on the screen, but the domain is really something that is singular to every companies. So it should really be something central to developer. I think that's my point of view. But probably because of the the resistance of it changed a lot in the way of working as opposed to the traditional way of working. And I think it's probably one of the main reasons why it's not that applied in the sector.
What would be alternatives if it's not yet so much applied? And what are alternatives that customers would choose instead?
Hard to tell. I think, well, you can write software that works perfectly without applying truthfully DDD methodology, let's say. That has been done for 60 years now, since the beginning. But what we saw that is typically at some point the software is flagged as legacy. No one wants to touch it anymore. And either you throw it away or you live with it. So it's not well. The alternative is what has been used so far, which and is the focus on the technical aspect before the domain aspect. And technical aspect can change, where the domain concept not that much usually.
So you mentioned about the software becoming legacy, and then people, and then no one wants to touch it anymore. But in my naive solution for that, wouldn't it just be a question of constantly refactoring and reducing the technical debt and keeping up with things, even if, for example, it was written in Java and now you want to rewrite it completely in Scala, something along those lines.
Yes.
Wouldn't that help avoid that?
Yeah.
problem.
It's one way to get rid of the legacy. It's either begin from scratch or refactor and maintain. But at some point, some solution might become so complex that, well, it's kind of what banks are currently facing with their mainframe. They still have to deal with them. They are still written in COBOL. They pay a lot for the license. They pay a lot for the maintenance. They would like to get rid of, but at some point, it's well. Now there is the risk evaluation, of course, which the banks are facing. But yeah, you can always throw away a legacy system, but you have to take account for the risk and find a viable solution. That's the answer.
Yeah, I'm just from what I understand, at least based on what you mentioned, is that DDD is a way to avoid that, right?
It aims to.
Yeah.
It's not like, well, it's not like it's one in the slide, but I didn't. It's not a recipe. There is not a cookbook that you can follow and say, okay, I'm doing DDD now. My software will be good for years and years. No, it's not like that.
It's like
It's practices and principle that you have to apply. It's also very iterative. You learn from your mistakes and change the way you are working to fix those mistakes. Yeah, well, that's how we lived it at Proximus. We made some mistake and we changed.
I guess one of the challenges is not just so much of the tech lead trying to pitch to the business that this adoption is necessary, but also trying to explain to the developers, the junior developers that just joined, this is what we're going to use.
That's what I say. It should be part of at least high level, but explain what it is, why it's important to focus more on the domain than on the technical aspect. And that wasn't part of when I was at school. It was eye-opening for me. That okay, yeah, I've been doing software wrong for now for years. Well, I didn't focus on what's important in the software.
Okay, thank you.
No more questions?
All right.
Thank you.
Thanks a lot, Philippe.
Thanks for the attention.
Thank you.